You know, it's funny how we humans can be so brilliant and then, completely clueless, all in the span of, 5 minutes.
Yeah, we're a complex species, that's for sure, full of contradictions.
Totally. Like, T.S. Eliot called us hollow men, right? But then Shakespeare saw us as, noble in reason.
Yeah, it really makes you wonder what's really going on in our heads.
It does. So today we're diving deep into this chapter on thinking and language to try to sort it all out.
It's a fascinating area. We're going to unpack how we process information, how we solve problems, make decisions, the whole thing.
And language. We can't forget that.
Right. How we use it, how our brain handle it, how it shapes the way we think, all of that. And we'll even compare ourselves to other species to see where we stand cognitively, just for fun.
Love it. So basically, we're on a mission to understand our own minds.
Yeah, exactly. It's about understanding not just what we think and say, but the how and the why behind it all. So by the end, we should have a much clearer picture of how our thoughts, judgments, and communication all work together.
Sounds good to me. Where do we even begin with something this big?
Well, we've got to start with the foundation, and that's cognition. It's basically all the mental stuff we do, thinking, knowing, remembering, communicating.
Okay, so, the basics of how our brains work.
Exactly. And a key part of that is concepts. Think of them like mental folders where we group similar things together.
So instead of seeing every single dog as a unique creature, we have this mental category for dog.
Right. It's all about efficiency. Imagine trying to process every single furry, four-legged creature as totally new. Our brains would be overloaded. These concepts simplify things. Now, within those concepts, we often have prototypes.
Prototypes, like the most typical example that comes to mind.
Exactly. Think of a bird. What pops into your head? Probably a robin or a sparrow, right? That's your prototype. Now think of a penguin. Still a bird, but less prototypical.
True, yeah. So it's kind of like our mental benchmark for a category.
Yeah, and those benchmarks, those prototypes, can actually influence our memories. It's kind of wild.
Wait, what do you mean?
Well, there's this study with Belgian students where they showed them faces with mixed features and asked them to categorize them. And then later, when they tried to remember those faces, their memories had shifted more towards the prototype of the category they had put them in.
Whoa, that's so weird. So it's like our brains are always trying to make things fit into neat little boxes, even if they don't quite fit.
Yeah, it's about making sense of the world. But you're right, sometimes those boxes get blurry.
Right, like is a tomato of a fruit or a vegetable? It definitely doesn't fit the classic fruit prototype.
Exactly. Or is a 16-year-old a girl or a woman? Where do you draw the line? And this fuzziness can be a problem. Think about heart attack symptoms. If someone's symptoms don't match the typical chest-clutching image, they might not realize what's happening.
Oh, wow. Yeah, that's scary.
And it can affect how we see prejudice, too. If someone's behavior doesn't fit our preconceived notion of what prejudice looks like, we might miss it. So yeah, concepts simplify, but they can also create blind spots.
So that's how we build these basic units of thought, but how do we actually use them to solve problems?
That's where we get to see our rational side in action. We have a few tools in our problem-solving toolbox. There's trial and error, which is pretty straightforward. Think about Edison trying out thousands of materials before he found the right one for the light bulb filament.
Oh, okay, that makes sense.
What else? Algorithms. They're basically step-by-step instructions that guarantee a solution. The downside is they can be a real pain, super time-consuming.
Yeah, I can see that.
Like if you're trying to unscramble the letters in, how about SPLOEOCHYG?
Oh, gosh, yeah.
An algorithm would have you trying every single combination until you hit psychology. Not very efficient.
Nope. So our brains must have a faster way of figuring things out.
Oh, yeah. Heuristics. Think of them as mental shortcuts. They're faster, but more prone to error. Instead of trying every combination, you might look for common letter pairings.
Oh, that's clever.
It is. And then there's insight, that classic aha moment.
Oh, I love those. Like when the solution just pops into your head out of nowhere.
Exactly. Like in that story of Johnny Appleton rescuing the robin from a deep hole using sand.
Oh, yeah, brilliant. He just suddenly realized he could raise the bird up by filling the hole.
And brain imaging studies show there's actual specific activity in the frontal lobes right before that insight, and then this burst of activity in the right temporal lobe as the aha hits.
That's fascinating. But we all know problem solving isn't always that smooth. What gets in our way sometimes?
We definitely have our mental roadblocks. Confirmation bias is a big one. We tend to look for information that confirms our existing beliefs and ignore anything that contradicts them.
So, we're kind of wired to protect our worldview.
Yeah, in a way. There's this classic experiment called the 2-4-6 rule. People are told to figure out a rule based on a series of numbers. They could test their hypothesis, but they mostly just try to confirm it, not disprove it.
So they miss out on potentially crucial information because they're so focused on being right.
Right, and this bias plays out everywhere, in politics, healthcare, you name it. Then there's fixation, which is getting stuck in one way of thinking.
Like that matchstick puzzle, where you have to make 4 triangles out of 6 matches.
That's a perfect example. People get stuck because they're trying to solve it flat, not realizing they need to build a pyramid.
Oh, yeah. It seems obvious once you see it, but it's so hard to get there sometimes.
Exactly. And then there's mental set, basically approaching new problems with the same old strategies.
Sticking with what we know, even if it's not the best approach.
Yeah, our past successes can create tunnel vision, like those letter sequences. OTTF, then JFMA. If you're thinking numbers for the first one, you might miss the months of the year for the second one.
Ah, I see. So we have these ways of thinking and problem solving, but also these pitfalls we can stumble into. How does all this play out in our everyday lives?
A lot of our decisions, especially the quick ones, rely on intuition. It's like that gut feeling, those automatic thoughts.
But don't those sometimes lead us astray?
They can, for sure. They're often helpful, but sometimes they lead to predictable errors in judgment, like with the representativeness heuristic. We judge things based on how well they fit our stereotypes.
So we might think someone's more likely to be a professor than a truck driver just because they like poetry, even if it's statistically less likely.
Exactly. It's about judging based on how typical something seems, not necessarily the actual odds. And that can lead to some problematic biases, especially in social situations.
Makes sense. What about the availability heuristic? That one always trips me up.
That's the one where we judge likelihood based on how easily something comes to mind. Like, vivid or recent events seem more likely, even if they aren't. Think about casinos. The flashing lights and sounds of wedding make those jackpots seem way more frequent than they are.
Sneaky.
Right. And that's why we might fear things like plane crashes more than car accidents, even though statistically, driving is way more dangerous. A single powerful image can really mess with our perception of risk.
It makes you realize how much our emotions can influence our judgment. Speaking of feeling certain, isn't it dangerous when we're super confident in a decision? I mean, doesn't that sometimes backfire?
It definitely can. Overconfidence is a real thing. We tend to overestimate our abilities and knowledge.
So even when we're dead wrong, we can feel really sure of ourselves.
Yep, that's the tricky part. Studies show people often overestimate their performance on all sorts of tasks. And overconfidence can have serious consequences, like in finance, where people might make risky investments based on a false sense of knowing what the market will do.
Or like when we think we can finish a project in a day and it ends up taking a week.
Exactly. The planning fallacy. We're notoriously bad at predicting how long things will take. But there's also research that suggests a little overconfidence can be a good thing. It can make us more resilient and motivated.
So it's like a double-edged sword, kind of.
Yeah, it is. The key is to get accurate feedback on our judgment so we can adjust our confidence accordingly.
That makes sense. What about when our deep-seated beliefs are challenged? How do we react then?
That's where belief perseverance comes in. We tend to cling to our beliefs even when the evidence against them is strong. There's this study on capital punishment where people were presented with mixed evidence, and guess what? Both supporters and opponents ended up even more convinced of their original positions.
So they just kind of interpreted the evidence to fit their existing views?
Exactly. It's like they were motivated to protect their beliefs. And you see this everywhere, in political debates, arguments about climate change, even personal relationships.
Wow, so even when we're presented with facts, we can still dig our heels in.
We do. But there's a strategy to combat this. Consider the opposite. Actually think about why your belief might be wrong. It helps loosen that grip on your initial idea.
That's a good tip. Now, how much does the way information is presented, like the framing, affect our decisions?
Framing is hugely powerful. Even with the same information, how it's presented can dramatically change our choices. Marketers and politicians know this well.
Like how gun safety and gun control can evoke such different responses.
Exactly. Or think about medical treatments. A surgery with a 90% survival rate sounds much better than one with a 10% mortality rate, even though it's the same thing.
True. I'd definitely pick the 90% survival rate, even if logically it's the same as a 10% chance of dying.
Right. And things like default options have a huge impact too. Like with organ donation, if you have to opt in, fewer people do it. But if you're automatically enrolled and have to opt out, more people stay in.
Wow, so they're basically nudging people towards a particular choice just by how they present the options.
Exactly. So we've talked about how intuition can trip us up, but the chapter also says it's not always a bad thing, right?
Yeah, sometimes our gut feelings are spot on.
They are. Intuition can be a form of expertise. Think about a chess grandmaster making a move almost instantly. They're not consciously thinking through every possibility. It's more like years of experience guiding them.
Or like a doctor making a quick diagnosis.
Yeah, those are great examples. And interestingly, sometimes conscious thought can actually interfere with those honed skills, like choking under pressure.
Yeah, makes sense. So intuition is really about recognizing patterns and making quick judgments based on past experience.
Yeah, and it's usually adaptive. Those gut feelings are often based on learned associations that have kept us safe. But we can't always rely on them. The trick is to know when to trust them and when to slow down and analyze.
So striking that balance between our gut and our analytical brain.
Yeah, and for complex decisions, sometimes letting our unconscious mind process things for a bit can actually lead to better outcomes.
Wait, really? So just step away from the problem and come back to it later.
Yeah, it's like giving your brain time to mull things over in the background. But it's important to gather information first and then let it incubate. And then, of course, there's still a role for deliberate thinking, weighing the pros and cons and all that.
So it's not just about being logical or going with your gut. It's about using both effectively.
Exactly. Thinking is a dynamic process. Now, what about creativity? Where does that fit in?
Ooh, good question. It seems so mysterious and magical.
It is. It's the ability to come up with new and valuable ideas. Think about Andrew Wiles solving Fermat's last theorem after, centuries of mathematicians trying.
Yeah, that's some serious brain power.
For sure. And research suggests there are 5 key components to creativity.
Okay, I'm all ears.
First, expertise. You need a solid base of knowledge. Second, imaginative thinking skills, being able to see things from new angles, make unexpected connections.
Like how Copernicus reimagined the solar system with the sun at the center.
Exactly. Then you need a venturesome personality, someone who's willing to take risks, embrace the unknown.
So not afraid to fail, basically.
Right, and intrinsic motivation, you got to be driven by passion, not just external rewards. Think of someone like Newton, driven by pure curiosity about the universe.
That makes sense. What's the fifth one?
A creative environment. Surround yourself with people who inspire you, who challenge you. Mentorship is huge, and just being in a place where new ideas are welcomed and nurtured.
So it's not just about individual brilliance, it's about the context, too.
Yeah, it all works together. And the good news is there are things we can do to boost our own creativity.
Really? How?
Well, for one, become an expert in something you're passionate about. Then give yourself time to think, to let ideas incubate. Even just letting your mind wander can be helpful.
So like scheduled daydreaming. I can get behind that.
It works. And experiencing other cultures can be a huge spark, too. It challenges your assumptions and forces you to see things from new perspectives.
That's so true. Travel can be so eye-opening.
It is. Now, before we move on to language, what about other species? Do they share any of our cognitive abilities?
Ooh, that's always a fascinating question. I mean, we tend to think we're the most intelligent beings, but is that really true?
Well, research is showing us that other animals are much smarter than we used to give them credit for.
Like how smart?
Well, there's this African gray parrot named Alex. He could understand numbers, categorize objects. It was an amazing way. And studies have shown black bears can form concepts. Even pigeons can learn to differentiate categories. And chimps, they've shown actual insight while problem solving. Some can even plan for the future, and some even seem to have a basic understanding of what others are thinking, which is pretty wild.
So like, they know what other chimps are thinking.
It seems like it. To some degree, it's called theory of mind. And it's not just individual smarts. Some animals have cultures, too.
Wait, what do you mean?
Like chimps, they have these learned behaviors they pass down, like how to use tools or groom each other.
That's amazing.
It is. Baboons can recognize each other's voices, and some species, like dolphins and elephants, show self-awareness. Chimpanzees have even shown behaviors that look a lot like altruism and cooperation. It really makes you reconsider what intelligence even means.
It does. So we're not the only ones with complex mental lives.
Yeah. Definitely not. And the chapter even gives us some funny midterm grades for humans. B for decision-making, B+ for problem-solving, and A for cognitive efficiency and creativity.
So we have room for improvement, basically.
Always. But now, let's talk about language. It's what really sets us apart as humans, wouldn't you say?
For sure. It's how we share ideas, build knowledge, connect with each other. It's pretty amazing.
It is. It's like we're broadcasting our thoughts using these intricate sound patterns. Language is our ultimate tool for communication, whether spoken, written, or signed.
And when you think about it, it's kind of a miracle that we can take thoughts, turn them into words, and have someone else understand exactly what we mean.
Right. So how does this magical system work? Well, there are three key elements: phones, morphemes, and grammar.
Okay, break those down for me.
Phonemes are the smallest units of sound in a language, like the B sound, the A sound, the T sound, and BAT. English has about 40 of them.
Okay, and morphemes.
Those are the smallest units that carry meaning. So a word like cat is a morpheme, but so is a prefix like un or a suffix like ed. And then grammar is the set of rules that tells us how to put all those pieces together.
Oh, so it's like the instruction manual for language.
Exactly. And what's amazing is how much complexity you can get from those basic building blocks. A few dozen phonemes become thousands of morphemes, which can then create an almost infinite number of sentences.
It's like a code, but one that allows for endless possibilities.
It is. And we're hardwired to learn it. I mean, even without any other sensory input, language can create a profound sense of connection and understanding. It's like woven into our very being.
Totally. So how do we actually learn this incredibly complex system?
Well, there's this idea called universal grammar, proposed by Noam Chomsky. He says we're born with an innate understanding of the basic structure of all languages, like a blueprint in our brains.
So we're pre-programmed for language, in a way.
In a way, yeah. But some argue that we learn it by recognizing patterns in the speech we hear. It's probably a bit of both. We have this biological readiness, but then our environment shapes the specifics.
That makes sense. Nature and nurture working together.
Right. And a great example of that is Nicaraguan Sign Language. Deaf children with no existing sign language model spontaneously created their own language with its own grammar. It's incredible.
Wow, so our brains are just wired for language no matter what form it takes.
It seems that way. And language development in kids is really fascinating. Even before they can talk, babies are absorbing a ton of information.
Like little sponges.
Totally. Around 4 months old, they can already distinguish between different speech sounds and even start to match those sounds to faces.
Wow, that's really...
It is. That's the beginning of receptive language, understanding what others are saying. Around 6 months, they start to recognize familiar objects by name. And by 7 months, they're figuring out how to break down speech into individual words.
So they're little linguistic detectives.
They are. And then comes productive language actually speaking. Around 4 months, they start babbling, trying out all sorts of sounds. By 10 months, their babbling starts to sound more like the language they're hearing.
And then those first words. It's so exciting.
It is. Around a year old, they start using single words to communicate. Then around 18 months, they start putting 2 words together, like want juice or mummy up.
Telegraphic speech. So cute.
It is. And there's this idea of a critical period for language learning. Basically, there's a window of time early in childhood when our brains are primed for language acquisition.
So if a child doesn't learn language during that time, it becomes harder later on?
Yeah, it does. It's not impossible, but it takes more effort, and they might never reach the same level of fluency.
That's why it's so important to talk to babies and young children, even if
Good.
they can't respond yet, right?
Exactly. They're absorbing everything. And this also explains why learning a second language as an adult is so much harder. We're past that optimal learning window.
Makes sense. Now, what about children who are born deaf? How does language development work for them?
Early language exposure is just as crucial for deaf children. For those born to hearing parents who don't sign, there can be a big delay in language development. Research shows that deaf children who learn sign language from birth develop language skills at a similar pace to hearing children learning spoken language.
So sign language is just as powerful and complex as spoken language.
It is. And this is a big part of the debate about cochlear implants. They can allow some deaf children to hear, but some in the deaf community argue that sign language is a rich and complete language in its own right.
It's about preserving their culture and identity.
Yeah, exactly. And it's fascinating how our brains adapt. People who lose one sense often have heightened abilities in others, like deaf individuals might have enhanced visual processing. But despite the challenges, deaf children who learn sign language go through similar language development stages as hearing children. It shows how deep the drive to communicate is.
It's like a fundamental human need. Now, what's happening in our brains when we use language?
It's a complex process. It mostly happens in the left hemisphere, and damage to that area can cause aphasia, which is an impairment of language abilities. 2 key areas are Broca's area and Wernicke's area.
Those names ring a bell. Refresh my memory.
Broca's area is in the frontal lobe, and it's mainly involved in producing language. Wernicke's area is in the temporal lobe, and it's all about understanding language.
So one's for speaking and the other's for listening and reading.
Sort of, but it's more nuanced than that. Modern research shows it's not just about those two spots. Language processing involves a whole network of brain regions working together, and different parts of the brain handle different aspects of language, like nouns versus verbs or different types of sounds. Even being bilingual changes how your brain processes language.
So it's like a whole orchestra of brain activity going on.
Exactly. Now, the big question, do other species have language? We talked about their cognitive skills earlier.
Yeah, it seems like some are pretty intelligent.
Good.
But do they have actual language like us?
Well, for a long time, people thought language was unique to humans, but research on animal communication has really challenged that view.
Like how?
Well, there's evidence that human language might have evolved from gestures. And even now, we use gestures all the time when we speak. And some animals have really sophisticated ways of communicating. Monkeys, for example, have different alarm calls for different predators.
Wow, so they're not just making random noises, they're actually conveying specific information.
Right. But the real debate is about apes and their ability to learn and use human language systems like sign language. There were those early studies with chimps like Washoe who learned a lot of signs, but there was skepticism about how complex their communication really was.
So could they string those signs together into grammatically correct sentences?
That was the question. Later research with bonobo showed some could actually understand spoken English syntax, which is pretty amazing. And then there are those super smart dogs who've learned hundreds of words, so the lines are definitely blurry.
So they can communicate, but it's not clear if it's on the same level as human language.
Right. Humans also have unique abilities like following someone's gaze, and we have this special gene, FOXP2, that's involved in speech. But still, this research has really made us appreciate the communication skills of other species.
It's so cool to think about the different ways creatures communicate.
Yeah.
So let's talk about that chicken and egg question.
Huh.
Does language shape our thoughts, or do our thoughts shape our language?
It's a tough one. Benjamin Whorf had this idea called linguistic determinism. He said that language determines thought. Like, if you don't have a word for something, you can't think about it. But
Okay.
that's probably too extreme.
Yeah, I can imagine things I don't have words for.
Right. A more balanced view is linguistic relativism, which says language influences thought. Like, studies show that people speaking different languages might experience emotions differently based on the words they have to describe them.
Interesting. So our emotions are shaped by the language we use to express them.
In a way, yeah. And bilingual people often feel different depending on which language they're using. And research has shown that language can affect how we perceive and remember things like colors.
Wow, so language really gets into our heads, even on a perceptual level.
It does. Even subtle things like using gendered pronouns can subtly influence our perceptions. The point is, expanding our language abilities expands our capacity for thought.
That makes sense. So the more words we have, the more nuanced our thinking can be.
Exactly. And there's the bilingual advantage. People who speak multiple languages often have better attention and cognitive control, and even show benefits later in life, like delayed cognitive decline.
Wow, so learning a new language is like a brain workout.
Kind of, yeah. It strengthens those mental muscles. Now, what about thinking in images? Is it all just words in our heads?
Good question. I feel like I do both. Sometimes it's words, sometimes it's pictures.
We do both. Thinking in images uses our implicit memory. Like, when you're driving a familiar route, you're not necessarily narrating every turn, you're just doing it.
True. It's like my body just knows what to do.
Exactly. And lots of creative people think in images. Artists, musicians, scientists. Einstein famously said he thought in pictures.
That's so cool.
It is. And there's research showing that simply imagining doing something activates the same brain areas as actually doing it.
So like mental practice actually works.
It does. Athletes use it all the time, visualizing themselves performing perfectly. And studies show it helps with academic goals too. But the key is to visualize the process, not just the outcome. Like, instead of imagining yourself getting an A, imagine yourself studying, going to class, actively engaging with material.
So focus on the actions that will lead to the goal.
Exactly. So we use both words and images to think, and they interact in fascinating ways.
It's like our brains are these incredible multimodal machines.
They are. So to bring it all back around, thinking and language are deeply connected.
Yeah, we've covered a lot of ground today, from the basic building blocks of thought to these mind-bending cognitive biases.
We've looked at how we solve problems, make decisions, the different strategies we use, the pitfalls we encounter, and we've explored the wonder of language, how it shapes our thoughts, and how it connects us to other humans and even to other species.
It's been a wild ride. So much to think about.
It is. But here's the takeaway. While we're capable of incredible things, our thinking and language are also subject to these biases and influences.
Right, those mental shortcuts and blind spots we talked about.
Exactly. And knowing about them helps us make better decisions and communicate more effectively.
So listeners, pay attention to your thinking. Are you falling for confirmation bias? Are you framing things in a way that limits your options? The more aware we are, the better we can navigate the world.
Couldn't have said it better myself. The human mind is a fascinating thing, full of potential and quirks. Keep exploring it.
Thanks for joining us on this deep dive. Until next time.